In the last lecture, we have introduced the physical quantities gravitational potential energy and gravitational potential. And we have emphasized that they are both scalar quantities. So now we want to see how we can find the resultant gravitational potential if we have more than one massive object that's present. So if there are two masses or more that are present, then the resultant gravitational potential is given by the scalar addition. Note that this is very different from how we would add gravitational field strength. So a good example would be a point P that's between the Earth and the Moon. To find the resultant gravitational potential, we just have to add the contributions from Earth and Moon. Take a look at example 5. You have a spaceship that goes from Earth to Moon, and we need to calculate the gravitational potential at the zero gravity point. And in part B, we have sketched the variation of the gravitational potential, and part C to find the minimum energy required to send the spaceship from Earth to Moon. We have already found where the zero gravity point is in the previous example, that is closer to the Moon than to the Earth, right? So using the formula for gravitational potential, we just have to substitute the value of x into the expression. Note that the contributions from the Earth and the Moon are both negative, right? And as a result, you will get a gravitational potential that is also negative. When we try to sketch the graph, one thing we realize is that the zero gravity point is actually the point whereby the gravitational potential is maximum. And it decreases as you go towards the Earth as well as towards the Moon. Okay, it's actually a maximum point. Although it's a sum of two negative numbers, but it will end up being the maximum point. Alright. In part C, we will need to find what is the minimum energy that's required. Okay, so if you start off from the surface of the Earth at this point, this is the amount of energy, the gravitational potential energy that the spaceship has, right? In order for it to reach the Moon, how much energy is needed? It may be tempting to say that it is a difference between the gravitational potential energy on the surface of the Moon and on the surface of the Earth. But if you look carefully at this graph, that is not so, because in order for you to reach the Moon, you must be able to clear this height first, right? This difference first before you can reach the surface of the Moon. So that is actually the difference that we are interested in, right? This increase in gravitational potential energy has to be supplied by the spacecraft. Okay, so the work done by the spacecraft engines or the jet fuel has to be given by the difference between these two values. So we just sub it in and we can find the minimum energy required to send the spaceship from the Earth to the Moon.